Hi everyone, welcome back to my YouTube channel. So today we'll be discussing few NEET questions that were asked in the year 2024. Okay. So now for the first question, they're asking you to identify the most stable carbocation. So when they're asking you to find the stable carbocation, there are two electronic effects that enhance the stability of carbocation. One is inductive effect and the second electronic effect is hyperconjugation. It is hyperconjugation. Okay. So inductive effect is nothing but electron transfer through a sigma bond. So you can have two groups. One is an electron donating group and the second is an electron withdrawing group. So when you have electron donating group, it has plus I effect. And when you have electron withdrawing groups, it has minus I effect. So all alkyl groups are electron donating groups. And in case of electron withdrawing, your nitro and carbonyl compounds are electron withdrawing. So now electron donating groups will stabilize the carbocation, whereas your electron withdrawing group will destabilize the carbocation. Then hyperconjugation. So hyperconjugation is also called as no bond resonance, wherein the beta carbon will donate its sigma bonded electrons to satisfy the electron deficiency of the carbocation. So when you have more hyperconjugation structures, more stable will be the carbocation. So based on these two electronic effects, we conclude that a tertiary carbocation surrounded by three alkyl groups will be more stable, and then your secondary and then your primary. Is that clear? So now of the four options, first you have to analyze which one is a primary carbocation, secondary and tertiary. So if you see option A, it is a secondary carbocation. Option B is a primary carbocation. Option C is a tertiary carbocation, and again option D is a secondary carbocation. So of all the four options available, your option C is tertiary and therefore it is the most stable among the following options. Okay, I hope that's clear. Now we'll slowly go to the next question. So they have given five metal ions. You will have to identify which one has the same spin only magnetic moment. Okay, so to calculate spin only magnetic moment, we know the formula to be n into n plus 2 root Bohr magneton. And here in this case, your n is the number of unpaired electrons. Okay, so first you must know the configuration of each metal, write and then check how many unpaired electrons are available. Okay, so if you see option A, it has titanium. Okay, so titanium 3 plus ion. First you write the configuration of titanium. It is S2D2. If you see titanium 3 plus, it will be having D1 configuration, which implies it is having what? One unpaired electron. Is that clear? Now move to option B. So now they have given a chromium metal. So chromium, we know the configuration is S2D4. Okay, so now chromium 2 plus will be having D4 electronic configuration. That means 4 unpaired electrons. Now go to option C. It is manganese. Okay, manganese, the configuration is S2D5 and manganese plus 2 will be having D5 configuration, which means 5 unpaired electrons. Okay, now option D. Option D, they have given iron. So iron, the configuration is FeD6. So now iron plus 2 will be having D6 electrons in it. Okay, so if you see D6 electrons, D orbitals, if you fill the electrons, 1, 2, 3, 4, 5 and 6. Okay, which means it is having 4 unpaired electrons. Okay, now moving on to option, the last one, that is option E. they've given scandium. Scandium, the configuration is S2D1, and scandium 3 plus means all electrons are donated and it is having D0 electrons. Now, comparing the options, you can see option B and option D has how many unpaired electrons? Equal 4 unpaired electrons. So their spin only magnetic moment will be equal. So when you substitute here, your mu will be 4 into 4 plus 2, 6. Okay, root. So it is root 24. That will be approximately 4.9 Bohr magneton. Okay, so for this question, the answer is option D, B and D. Okay, so first you have to write the configuration for all the metals they have given and compare the number of unpaired electrons, and it will be easier for you to solve the question. Now, this is an easy question. The third one, they have given some complexes and they are asking you to identify which isomerism will each complex undergo. So now if you see, it is a cobalt complex that has nitro as a ligand. We know nitro is an ambidentate ligand. Your nitrogen can be coordinated to the metal as well as your oxygen can be coordinated to the metal. So it is an example for what? Linkage isomerism. So you check for options that has A2. Okay. So option C and D has that. So you can straightway eliminate options A and B. So one important, not trick, a time saving hack is in competitive exams is that eliminating options. So when you eliminate the options quicker, it will be easier for you to solve the paper fast. Okay, so now if you see option, come to the complex B. So it has bromine outside the coordination sphere and sulfate is present as a ligand. It can act as ions. Okay, when bromine is outside, you will get a precipitate, whereas when sulfate is outside, you will be getting another precipitate. So it is an example for ionization isomerism. Okay, so option B is 3. So you can straightway select B and eliminate D. So by just looking at the first two complexes, you can finish this question. But moving on to option the third complex, they have given two complexes together. That is an example for coordination isomerism. So C will come to be 4, and in option complex D, you are having 6 water molecules as ligands that functions as a solvate isomerism. Okay, water is a solvent and that can act as a solvate isomerism. So you will have option D. Okay, next. So this is also an easy question. Now the fourth one, they are asking you which is the correct plot for the Arrhenius equation. Okay. So we know Arrhenius equation, it what does it relate? It relates how rate constant depends on temperature. Okay. So according to Arrhenius equation, K will be equal to A e to the power minus EA divided by RT. So now observe the four options. So in all your four options, there is ln K. Okay. So you will have to take ln to this equation. So when you take ln, it will be ln K is equal to ln A minus EA divided by RT. So now your ln K is your y-axis and 1 by T is your x-axis. So straight line equation, your slope will be what? Negative EA divided by R, and you have an intercept that is ln A. So how will your graph be? Ln K versus 1 by T. It is a negative graph because your slope is negative, and then you have an intercept. So you'll have to start somewhere, not exactly from the origin. So your graph will somewhere look like this. Okay, so which option has that? Option C is having that graph. So option C is the answer. Here K is the rate constant, A is the frequency factor, EA is the activation energy, R gas constant, and T temperature. So Arrhenius equation relates the dependence of rate constant with temperature. So now moving on to our final question. that is SN1 reaction. They have given four compounds. You will have to identify which one undergoes SN1 to a faster rate. So before solving the questions, you will have to know certain facts. So SN1 is a two-step process. The first step is carbocation formation and the second step is nucleophile attack. So now since carbocation is being formed in the first step, you will have to check for the stability of carbocation. More stable the carbocation, more faster will be the SN1 reaction. Okay, is that clear? So if you see this bromine is a leaving group, it will leave off, it will be cleaved off. Okay, so what is the carbocation that you will be left with? You will be left with a cyclohexyl carbocation. Now this there are no pi electrons, or there are no electron donating groups that can stabilize this carbocation, therefore it is not stable. Now moving on to option B. Option B, again bromine is the leaving group and you will be having what? Phenyl carbocation. We know that phenyl carbocation is highly unstable. So this also will not be the option. Now again option C, bromine will be the leaving group. So what cation will be you be left with? Okay, so you will have something like this. This is your carbocation. Okay, so here this is a secondary carbocation. Okay, it has donating groups to stabilize. We will check option D and we will come for the answers. Okay, so now in option D, again when bromine leaves, you will be having a cyclohexyl ring with this cation. It is a primary carbocation. So when we were solving the first question, we discussed about what? Stability of carbocations, and we discussed that tertiary carbocation is more stable, secondary and then primary. So when comparing these four options, you have a secondary carbocation that is being stabilized with donating groups. Therefore, option C will undergo SN1 reaction at a faster rate. So, checking for the stability of carbocation when solving SN1 reaction problems is very, very important. So, I hope the problems, you were able to understand the problems that we discussed in today's session. And we thank you for your patient listening. Happy learning.